so we're going to go through this example. Key idea is electrostatic charge is all about the fact that opposite charges attract and like charges repel. We're going to go through one of the oldest examples in the book. I can't see if that's working or not. No, it's sort of working. Okay, it's sort of working. I haven't got the same volume of hair as other gentlemen in the room. Okay, so we've got our random student Bailey. Okay, that's much more beneficial. Our random student Bailey is going through the same experiment. He's featuring his new hairstyle. Now what will happen actually, so I want to use this as an example, so I'm going to use Oliver's hair because it's better than mine, and I'm going to find another person with a floppy bit of hair. So you'll notice that even though Lockie's hair is neutral, Oliver's hair is charged, correct? Yeah. But Lockie's hair is neutral, it still had an effect. It wasn't as impressive as it was on Oliver's head. So let's run through what this looks like. So I'm going to assume, I'm just going to simplify this a fair bit. I'm going to simplify this, sorry I've ruined your hair. I'm going to simplify this a little bit. We've got, in both objects, we've got a heap of positives and negatives. I'm just going to draw the same number so we've got about the same in each, correct? So the balloon's got some protons and some electrons, and the hair's got some protons and some electrons. So they both start with the same number in each. Happy with that? When I rub them together, which one of these is the insulator? The balloon. Okay, the rubber balloon's the insulator. So what's it going to do? It's going to take some electrons. So I'm just going to... But in this scenario, it's taken... So this has still got the same number of protons, but it's taken a few of these electrons from the hair. And now, the balloon is negatively charged. So I've got a balloon here with, and I don't like this pen, I've got a balloon here with, let's just say 10 electrons. What's wrong with saying it's got 10 electrons? It's going to have way more than 10, correct?
Yeah.
2, 4, 6, 8, 10. One more. And it's got 4. Just go with 4. Okay, so it's taken some electrons off the hair, and now we've got heaps of protons left in the hair. So that was an example of Oliver's hair. The hair over here is still neutrally charged. I'm simplifying this a lot. What would change about this though? Would I see the positives evenly distributed?
No.
I'd probably see that I'd have more, I guess the positives would be evenly distributed, but I'd probably find that some of these electrons are sitting on this side. Why are they sitting on that side? Because I want to get close to the positively charged hair. Does that make sense? When I brought it over to Lockie's hair though, why did it? Because I've got a positive and a negative object, so that makes sense, correct? They want to attract and we get the big impressive hair movement. When I brought it over to Lockie's hair, I had a little bit of that going on as well. It wasn't quite as impressive, but I had a little bit of that going on. Why?
Balloon was still charged.
Let's just draw the same balloon. I've got all these negative charges here and I've got some evenly distributed positive charges. What's that going to do to the negative charges in Lockie's hair? Where are they going to go? If you're this charge here or this charge here, do you want to be near all these electrons? So you're going to run away from that, causing Lockie's hair to become positively charged near the balloon. He's still neutral, but there's more positive charges near the balloon, which causes that attraction. Are we good with that? Cool. And now let's do the magic balloon trick. Can you charge that for me? I'll give you a magic balloon if you can charge it for me though. Let's see if this works. Alright, thank you. Beautiful. That is. So let's see how charged this balloon is.
That is so.
And there you've got a magic balloon, $5.
Yeah, there's more flowing water if we just do that.
What's that? What? It does make it. You didn't charge it, just charge it.
Did it charge the whole thing or just like the side of it?
It does, but it's not nearly as strong.
Yeah.
So why does that happen? Tell me, draw a diagram, why does that happen? So draw that example, I've just given you something very similar. So draw an example of why you think, if I simplify here, just assume my balloon's already charged. Why does that happen to my water? Why does it cause my water to bend towards the balloon? Have a think about that. I want you to draw it. I want you to draw it, not explain it.